All right, guys. So we've been discussing trig ratios, right? So now we're going to apply them to some right triangles. So we're going to see some different scenarios dealing with right triangles. So last time we were discussing, I mean, a lot of different topics, right? Sine, cosine, tangent, cosecant, all this good stuff. We were discussing degrees and minutes and such and so forth. So let's say we have this right triangle, right? And they give us one angle and they give us one side. So the ultimate goal is to have everything, to know all the three angles, to know all the three sides. So how do we attack this? Well, I would write down everything we know, right? So right now we know angle A. So let me get a nice little color out. Okay, so we know angle A, right? We know angle C. So we need to look for B. So that's going to be something that's kind of okay, kind of like going back to geometry. So if we know these two angles, right, and all three angles add up to 180, then we're good to go, right? So we could add them all up. We could add these two up, subtract from 180, or we could just go 90 minus this because we know that these two angles, A and B, have to equal to 90 because this one's already 90, right? So that's what I did here. So I did 90 minus 34 degrees in 30 minutes. But being that I have a minutes, I had to take 1 degree, and this is a little error that I saw in the homeworks, is that when you have to borrow 1 degree to make these 60 minutes. Some of you guys were writing it like this in your homeworks, okay? And then you were off by one total degree. Sorry, this is a six. This is a six. Okay. And you were off by one total degree. So remember, when you make this 60 right here, you're actually borrowing from the 90. So it has to go to 89. All right. So make sure you guys are you're cognizant of that. Okay. So you're 89 degrees in 60 minutes is a total of 90 degrees, right? And then we subtract and we get our angle B. Bada boom, bada bing. So now we're good. We have this. Okay. So we have all our three angles. Now let's find our A and our sides, our A and our B. Now, we know we have the trig ratios. We could use the trig ratios to our advantage. Let's start off with sine of 34 degrees in 30 minutes. So we have this right here. So sine means opposite over hypotenuse. So we have A over 12.7. Sine 34 degrees and 30 minutes is equal to the opposite over the hypotenuse. Okay. Well, how do I get A? Well, I want to get rid of this divide by 12, right? 12.7. So I multiply 12.7 to both sides, and I have this function right here. I get this one. Okay. Now, when you're putting in the calculator, you cannot put 30 minutes in the calculator. So we have to convert that back to decimals. Okay. So remember, we're going to take this number and divide by 60, and whatever decimal we get, we put it right there. Okay. So when you type this into your calculator, you're going to get A equals 7.9. Okay. So what about side B? How do we get side B? Well, side B would be almost identical. So now we're going to use cosine. So we're going to have cosine of 34 degrees in 30 minutes is B over, which is adjacent over hypotenuse. Now, we already know what this is in decimal form, so I'm just going to write that in decimal form. And how do we get rid of a divide by 12.7? We multiply by 12.7 to both sides. Okay, so let me get my handy dandy calculator. I'm going to type in 12.7 times cosine of 34.5, and I get a whopping 10.46. Well, actually, let's round it up to 10.47, which equals to B. So now we have our three angles and our three sides. So now let's practice. Let's practice doing two problems very similar. So we have one angle, one side. Well, technically we have two angles, right? Because we already know that it's a right triangle. So technically we have two angles and a side. So let's first figure out the other side. So we know angle A, angle B, and angle C. So right now, angle B is 32.7. Angle C is 90. So to get angle A, we go 90 minus 32.7. So we go 90 minus 32.7, which gives us a whopping 57.3 degrees. Okay, so now we have our three angles. So we're good. We're slowly churning the wheels, right? So now let's figure out the sides. I'm just gonna use sine of B, which is 32.7, and that would give me my opposite, B over 4.6. Okay. Now, what do? Well, I simply just move this divide by 4.6 to the other side by multiplying. So I'm going to have 4.6 times sine of 32.7. And that equals my B. So I type that in my calculator, 4.6 times sine of 32.7. And I get a whopping 2.40. I'm going to round up to the 10, from to the hundredth place, the second decimal place. Okay. And the process is going to be the same, but now I'm going to do cosine. So I'm going to do cosine of 32.7, which would be that's an A, not a 9, over 4.6. And then I do the same process. I put it on this side. And I need you guys to be able to be very good at this because on your homeworks, you're going to get a problem like this, okay? So 4.6 times cosine of 32.7, and I get 3.87 equals A. Now, quick, we have to go back. I failed to mention this. Notice this says millimeters, so I need to go back and I need to put the units, millimeters. Okay, because if you don't put the units, guys, the computer program might count it wrong. On your test, I might just put these answers, but I might just change the units. I might put centimeters, millimeters, inches. So all the numbers look the same, but the units are different. So be careful, be cognizant of that. Okay. Um, I like to rush it, right? I like to just do the math and I get all excited, but I always go back and I double check. All right, what units am I in? Okay, and I always put it in the units at the end. Okay. So be sure you do that too. So now number two is a little bit different, guys, because we still have two angles on the side. However, we now don't have the hypotenuse, and our angles are not in decimal. So we first need to convert this from minutes, and seconds to decimals. So we talked about this back in the angles section. Okay. So it's page 14 of your notes, right? So we have 12 degrees, 42 minutes, 38 seconds, right? And we just kind of put it over 60 for the minutes, put it over 3,600 for the seconds, and we could actually convert it to decimals. So that's kind of like what we did here, right? We put it over 60, put it over 3,600, and then we got our decimals and we just converted them, okay? So that's kind of what we're doing right now. We're going to do that to this problem. So the 22 stays 22. We're going to go 33 over 60. And then we're going to go plus 11 over 3,600. Okay. So 33 over 60 is that 0.55. 11 over 3,600 is 0.00. I'm going to go 31. Okay. So then I add that 0.55 plus 22, and I get a total of 22.553 degrees. Okay. Now we're only going to go to the 2 decimal places, so we're just going to leave it at 22.55. Okay. So that's angle B. So how do we get angle A? Well, we already know it. It's 90. Angle B is 22.55. So angle C has to be, we take 90 and subtract 22.55, and we get 67.45. So to get the missing angle, this one over here, angle C, all we do is take 90 and subtract. Okay. So now we have kind of like a dilemma. So what are we gonna use, right? So over here we're using sine, but if I use sine of B, that's opposite over hypotenuse, and I don't know that, right? So how do I figure this out? Um, what's a good trig ratio I could use? All right, and one of them that I would want to use would be tan. So I get tan of B, which is opposite over adjacent. Okay, so tan was actually, I mean, sorry, B is actually 22.5, and then we don't know the opposite. That's letter B, but we know the adjacent, which is 74. And guess what, guys? Look, we already know how to work this. If it's on the bottom, we just kind of bring it to the other side by multiplying it, and we get our B. So we go 74 times tan of 22.55, and we get 30 point, excuse me, 73 for B. Okay, so now we know B. So we A, still a mystery. B is 30.73. C is 74. Okay. Well, now we could just use Pythagorean theorem, right? We know A squared plus B squared equals C squared, right? In this case, A, I mean, the letters are a little off, right? But A is supposed to be our hypotenuse, right? So that would be our C squared. We could do that. Or we could just plug in our B, our new acquired B, and solve for sine of 22.55, which would be opposite, which is this one, 30. Well, actually, no, wait. We would, yeah, because then we're gonna get into flip-flopping. How about, yeah, I think it would be best just to do because look, if we continue, right, this is what I mean. If we continue, we're gonna have our hypotenuse on the bottom, which is gonna get into a little seesaw battle here. I mean, it still could be done. So let me show you. I'll just continue it. So what you want to do is you want to get rid of A. So I mean, divide by A. So we multiply by A. Okay. But then I don't want this. Like I want A by itself. So then I would divide by this. So it's kind of like a little seesaw battle that you get into. Kind of like when we did rationals. Okay, so you can't really see it there. But you're dividing 30.73 by sine of 22.55. And then, so these cancel. So A would equal to, actually right there, 80.8. So right here, this is this fraction. I know it's kind of hard to see. My handwriting's horrible, but that is what I'm doing. So you guys could do that. It's a little seesaw battle, right? Because I moved the A this way, and then I brought this back down. But it's good. It's good algebra skills, right? We could have done Pythagorean theorem, and we would have gotten the same answer. All right, we could have taken 74 squared plus what was B, 30.73 squared, added them, taking the square root, and we would end up still with 80.13. Okay. So on your homeworks, guys, you guys are gonna get problems like this, okay, for sure. So be careful, okay. Watch right here. This is probably key. So I'm gonna probably throw one or two that are in decimals, and then bam, throw you one that has minutes, and you have to remember to convert before you move forward. Okay. All right. Let's move on. So now what about we have a right triangle with two sides. So we technically know two sides and one angle, right? Because it's a right triangle, so we always know that one of the angles is 90 degrees. Okay. Well, this just takes us back to Pythagorean theorem days, right? So if we know two sides and we're trying to find the third, we just do Pythagorean theorem, right? So um and it's taking us back to our geometry days, right? So in this case, we know C, our hypotenuse, we're missing B. So that means we're gonna get C squared minus so C squared minus A squared, and then we take the square root and we get our B. So now we know our B. Okay, this is, oh, that's horrible. This is 44.77. Okay. So now that we know all our sides, now we can start figuring out the angles. And you're like, wait, what? We've always gotten the sine of an angle and figured out a side. We've never done it the other way around where we have the sides and we figure out the angle. So now, remember when I was discussing uh, this little concept from you guys last time, um, where this, if we wanted to go 1 over, this would equal to cosecant. And I said that cosecant does not equal to this. Remember that I was saying that this is the inverse. This is something totally different, right? We were talking about trig ratios. I think it was like 5.2 or 5.3. And we're using cosecant, and cosecant is just pretty much 1 over sine, right? Where we just kind of flip the ratios. But now that we're gonna do some undoing process of the actual trig function, we are now gonna do what is called the inverse. So now we're gonna use this bad boy. So now we're gonna use this button on the calculator. Okay, so here it goes. So sine of A, so that means we know the opposite over hypotenuse. So opposite over hypotenuse. Okay, so we know these numbers. But we want to get A. We want this angle. We want it to be by itself. So how do we figure out this angle by itself? Well, to undo the sine function, to undo it, you do something called the inverse of sine, which is this right here, the inverse. It's denoted by sine to the -1. And you have to do that to both sides. So you notice I kind of squeezed it in there right here. So now this inverse and this sine function kind of negate themselves out, leaving us just the A by itself. Now, we have sine inverse of 29.43 over 53.58. Now, you take out your calculators. If you have the TI-84, you're going to have to press the second button, the blue second button, and then sine. And then you'll get the sine to the -1. And then you just type in the fraction, and then you get your angle A, right? So that is when we use the inverse, when we're trying to find the angle, okay? So if we wanted to find angle B, yes, we could just subtract it from 90, right? So we go 90 minus 33.32, and we get a whopping 56. 0.68. Oh, these are all degrees. I don't know why I didn't write that, but these should be degrees. Okay. So be careful on this, guys. All right. Be very careful. Don't use this. Now we're using this. Okay. So we're gonna do a couple more problems, so we can get it going. All right. All right. So we have these two problems we're gonna work on. Okay. So first thing we want to do is we want to use Pythagorean theorem. Okay. Um, I deliberately wrote these letters off because I want you guys to start seeing that just because this is C does not make that the hypotenuse. Okay. So be careful. So we know our hypotenuse is subtracted by this. So we're going to have C equals to the square root of 15.3 squared minus 4.8 squared. So I'm going to put that in the calculator. You guys could pause the video and work on this. I would suggest do both of these right here. 5.3 squared minus 4.8 squared. And I get a whopping 14.52. Okay. So you're going to do the same thing here. So pause the video. You're going to do this same process on this one. Okay. So might as well kind of do them at the same time because we're practicing. All right. Do that now. Ready, set, go. And we're back. And I got this. I'll go 91. Okay. So I got my two sides already. Now, if I wanted to find my angles, so I pick A or I pick C. It doesn't matter. Okay. It really doesn't matter. So I am going to do sine of A, which would be opposite over hypotenuse. I do not know what sine of A is. I don't know what A is. I'm searching for A. But I do know my opposite. My opposite is 4.8. My hypotenuse is 15.3. So how do I get rid of this sine function? Well, you get rid of the sine function by doing the sine inverse. Ooh, I don't like that. Let's try black. By doing the sine inverse. And you do that to both sides, okay? So this will negate each other. And we're left with, I'm going to bring the sine inverse to the front over 15.3. Okay, because I just didn't leave room right here, guys. But it should be right here. All right, so sine inverse 4.8 divided by 15.3. And I get angle 18.28. Okay, so then how do I find angle B? I'm sorry, angle B we already know. How do I find angle C? Well, all I have to do is take 90 and subtract this. So 90 minus 18.28, and my angle C equals to 71.72. Okay. So number two, we're going to do the same process for number two, right? So we're going to have sine of A equals to opposite, which is 59.53, over hypotenuse, 223. Okay. We want to get rid of this sine. So what do? Sine inverse. These will cancel, sine inverse. So now we have A equals to sine inverse of 59.53 over 223. So sine inverse 59.53 divided by 223, and we get 15.48 degrees. Okay. We already know B's 90, so how do we get C? Angle C. This is angle. This should be angle. Well, all we do, we take 90 and subtract it from this. Well, not from this, but we subtract this from 90. There we go. So 90 minus 15.48, and we get angle C equals to 74.52 degrees. I didn't put degrees. Put degrees. Okay, guys, this is important for the homework. This is important for your test. You will have a test coming up as soon as we're done with the chapter. I think this is the last section, in fact. So be prepared for this. You're going to get a question like this on the test for sure. Now, when I teach this to my geometry kids, guys, I always go over trig ratios in my geometry classes. When I used to teach geometry, I used to love this section because we would go outside and we would actually measure the heights of the buildings and flagpoles and stuff using the trig ratios. So we would do these little measurements, and then we would get our angles, um, and then we would figure out our height, and we would do all this crazy cool stuff. And I wish we were in the classroom so we could do it in person, right? But unfortunately, due to this wave of that's happening right now to us, we have to do everything online. So I hope you guys can kind of just get a feel for it, right? So now, when we're discussing this, we also have things called angles or problems dealing with elevation and depression, right? Not depression like, oh, I'm sad, but depression means like in terms of angles, okay, guys? So think of the horizon. So like think of like you're looking at out into the ocean and you kind of see the horizon, right? Like you see the ocean, the earth, right? And anything going up from there, like your arm, like if you were to put your arm straight out, um, kind of like if you were doing I don't know, like you're signaling to somebody, pointing to somebody, and you pick up your arm above your head, like going towards the sky, that would be angle of elevation. But if you was to point towards the ground, like going down, that'd be like angle of depression, right? Because you're going down. Okay, so those are the two concepts that come up quite a bit. But the way we use this, and a lot of civil engineers do this, so they need to figure out the height of a building, or if the clearance of a certain building or a tower going up, uh, depending on power lines and such and so forth, right? What they do is they um they see the building or they see the object, right? So we have this object, right? Uh, they set a certain length that they move away from. Okay, so in this case, it's 123 feet. Okay, they're 5 feet 3 inches, so or 5.3 feet, right? Um, so we got to take that into consideration. And then what they do is they use this machine, and I can never say the word right. It's like cl- clinometer. I always get it wrong. I don't know why. I just cannot say that word. Uh, but it's a machine that allows you to find the precise degree of elevation when you set this little like stand here, and you it's like a little telescope actually, and you set it to where it's lined up with the very top of whatever you're trying to measure. Okay, so we have this person. He's using one of those machines. His degrees is 26 degrees and 40 minutes. So again, we need to convert this to decimals. So we just go 40 divided by 60, and we get 20. Actually 6.6. We'll say 26 degree. Oh, say 26.67 degrees. Okay, so that's what this is. This angle right here, right? So when you figure out the length, you got to be cognizant that you're starting 5.3 feet off the ground. Okay, so when we start doing the math, we're gonna actually just find this part. We're not gonna find out the entire flagpole because we're standing up. The machine's on a stand, right? So we're standing 5 feet off the ground, roughly 5 feet off the ground. So we know an angle, we know the adjacent, and we're trying to find the opposite. So what is that? That's tangent, right? So tangent of A equals opposite over adjacent. Okay. We know that tangent of 26.67 degrees will equal to A over 123, right? And we've done this before, right? If it's on the bottom, we just bring it to the other side, multiply, and we get A, right? So we get A equals to 61.77, but that's just this chunk right here. Remember, we still have to add this little part. So then we add 5.3 and we get 67.1 is the flagpole. And you know what? I did not put if it's meters or feet. Oh, I did. I put feet, so this would be feet. Okay. So I really love doing this project, man. Like in the class, we do the marquee, we do the length, the height of one of the buildings, we do the flagpole, we do a palm tree, uh, we do that big MW that's in the front of the school, guys. Man, I really wish we were on campus so we could do this project. This is one of the projects I really like to do, but unfortunately we're not. But uh, hopefully one day we can go back to campus. Okay, guys. Let's try another one. Okay, let's try some of these. Okay, so this is kind of you'll have problems like this on your homework and on your test, but it'll be a word problem. But I kind of already got like the measurements right. So we have 42 and 59 minutes. So let's convert that 59 minutes to decimals. So this is actually 42.98 degrees. So we're gonna have tangent of 42.98. Okay, we're on the ground level, so we don't have none of that. Oh wait, we're starting from a machine on a stand, or we're starting from 5 feet high. No, we're at ground level. Notice that we're on ground level, so we could just straight go into this. So opposite, which is A over adjacent, which is 99. So we get 99 times tan of 42.98 equals A. So we go to our handy dandy calculator, type this in, and voila, 92.20, we'll put 29 feet. And that's it. Nothing to it but to do it. Okay. Now, when we're doing with angles of depression, well, first let's convert this. So 40 divided by 60 is 60.67. So this would be 0.67. So now we really want to find this angle. Like this is the one that we need. This is the one they give us, but this is the one that we need because we want to do opposite over adjacent, right? And here, this angle is like, well, opposite would be somewhere over here, and adjacent would be somewhere over here. But we don't have that. But guess what, guys? Look at this. If I was to make this a straight line, it's a straight line. Those would be two parallel lines. Not only would they be parallel lines, we have a line that cuts them, known as a transversal. So this angle and this angle have something in common. They're alternate interior angles, right? So when they're alternate interior angles, that means they are the same. Isn't that wild? So knowing the depression, the angle of depression, we already knew what would be the alternate interior angle. So these geometry skills are coming into play today. And now this just becomes a problem like number one. We get tan of 44.67 equals to opposite over adjacent. So we get 14 times tan of 44.67 equals A. And we get 14 times tan of 44.67. And we get roughly 13.84. Okay. I did not put a unit here, so we're just going to leave it like that. Okay. So that's how we do these problems. Not too bad. Not too bad. Um, just using the tangent now. So the last bit of notes that we're going to go over is bearings. Okay. So this is something that I've been telling you guys in probably all the videos that Um, a lot of this stuff that we're discussing, the minutes, degrees, is used when we're doing navigation, right? Longitude, latitude, satellites in orbit, stuff like that. The ships also do this, like tanker ships, like people that ship stuff from China over here that's not on a plane. Well, actually, no, planes actually use this too. Um, but like tanker ships, right, in the water, right, navigation as well. So this idea of bearings, okay, um, what they always do is they always go by whatever a bearing is, kind of a navigation based off the direction of where is north, right? So um, they always go clockwise, and they always do it based off wherever the north is, right? So like kind of like the North Pole. So if I was to tell you 40 degree, my bearing's 40 degrees, I would have to say 40 degrees north, right? So it's like I was saying, this is my location. Oh, whoops. This is my location. Okay. I'm on this path, and I'm 40 degrees from north, right? So I'm this path. If I was to say I'm 180 degrees uh, from north, that means I'm actually going south, right? I'm going south. I'm going directly away, right? Because it's a straight line. I'm going directly away from north. If I was saying I'm 90 degrees, um, 90 degrees from north, that means I'm going east. 180 degrees, I'm going south. 270 degrees would be what? West, right? So that would be 270 degrees would mean I'm going west. Okay, so those are kind of some key ones that pop up. 90 means I'm going east. 180 I'm going south. 270 I'm going west. Okay, and it's always clockwise. So um, what happens, guys, is that you'll probably get a word problem. I don't think I threw any of these on the test or on the quiz. I mean, on the quiz, on the test or on the homeworks, but you might get one. I saw it. I saw this one in the book, and I really liked it. So let's suppose, as you guys know, there's a bunch of stations, right? Airports, uh, lighthouses, all these little GPS stations, coast guards, right? They always have stations, right? So let's say we have two. We have A and B, and they're both on the whole north plane, right? So they always do their bearings based off north. So Tower A detects a plane at point C, somewhere on point C. Okay, and it's at 61 degrees bearings. So that means from 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 the station's position, it's 61 degrees from north. That means they're going to go 61 degrees. So this is 61, and this is how they're detecting it. So it's kind of like those radars that you see in the movies. It's like beep beep beep, and they're like doing this, and you see it like in, and it's always like in like military movies that they're like, oh, there's 5 MiGs coming in, beep, right? So that's like, this is north, right? So they would be, the bearings is somewhere in this area, right? 35 degrees, right? um Now there's another station, right, that says that that same plane is 331 degrees from its path, right? So if you know that this is 61, right? Okay, so I'm going to kind of erase some of this green so we can kind of see my writing. If we know that this is 61 and this will make under 90 degrees, how much is this angle? Just curious. It'd be 29, right? Okay, if this is 29, that's 90, then this one would be what? This one would be, guess what? 61. See how that works? Crazy, right? This 61 pops up over here. Now, we know that they're 3.7 kilometers apart. Well, we could actually find the distance now. Let me just kind of erase all this so we can do it on the side here. So we could use either angle, right? Um, we're still going to try to find x. We're still going to try to find y. And we know the hypotenuse. So we could go sine of a, right? Yeah, sine of a, which is 29 degrees, which would equal to y over 3.7. And all we do is we bring this, whenever it's on the bottom, we bring it to the front. 3.7 times sine of 29 gives us, give me a second, let me get my handy dandy calculator. Sine of 29, and we get 1.79. We want to find x. Well, we do sine of 61, which would be x over 3.7. And what do? Same concept. Bring it to the front. 3.7 sine of 61. And we get x equals to 3.2. No, put 24. So y would be 1.79 kilometers, right? Because we're dealing with kilometers. X would be 3.24 kilometers. And that's how far away that plane is from each station. Isn't that wild? It's pretty good stuff. Okay, that's it, guys. Be on the lookout on the website because I'll probably post a review for your test pretty soon. Um, and then you guys can work on the review, study your notes, turn in your homeworks, and make sure you make corrections in your homeworks. All right, guys. So, because some of those questions that got wrong on the homeworks are going to be very similar to the ones on the test. All right. See you later.